So I will hand it back to you, or Annalene. Sorry about that. And you can give us an intro to Gus.
Thanks a lot. So first of all, don't forget to use the hashtag Contributing.today. And the speaker I'll be introducing is named Gus. He will talk to you today about TensorFlow. He's a senior developer advocate at Google. So we will talk about what TensorFlow is, a little bit more about the framework, why is it important, how can you use it in a development environment, and what tooling do we use generally. Also, some interesting links will be shared. And of course, he will mention how you can contribute yourself and add code to TensorFlow.
Hi, everyone. Can you hear me?
Hi. Yes, we can hear you.
Nice. Hello, everyone.
One more thing I wanted to add. We do have a code of conduct. We're here to learn cool things and be kind to each other. So let's do that. And the recording will be available at the latest tomorrow. So if you want to rewatch some of the awesomeness that you learned. So I'll pass that back to you, Gus, and you can get us started with some cool TensorFlow stuff.
Of course. Hi, everyone. Can you see my screen? I guess it's nice. Hi, everyone. So my name is Gus. I work on Google as AI developer advocate. And today I'd like to talk to you about TensorFlow, of course, which is what I do. I use TensorFlow every day, all day long. But I also talk a little bit about how the open sourcing works and how you can contribute to that. But before we get there, I'd like to first, let me organize my stuff here, sorry. Let me first start. So this is what we're going to talk about today. We're going to talk a little bit about machine learning. We'll talk about TensorFlow, community in OSS, and some examples where people are using machine learning, so to give you some ideas. Before we go into that, let's go to what's machine learning. So given, I was talking to the team before, and since not all of you are experts on what's machine learning, what's this kind of thing, how does it work, I decided to give a brief introduction. Of course, you're not going to become an expert, but you understand where are the differences, and I'll try to go over some of the terms that people use so you can understand better the rest of the presentation. You're probably a developer, so you kind of understand how coding works, right? So you go and you write your rules, and then you pass data through it, and you get answers. This is what developers do, right? So here we have an example of a function doing something. We give data, we get answers from that. If we extrapolate a little bit, games are also very clear, right? We have the brick game here. We can calculate the ball trajectory and stuff like that, calculate points. And so this is a good example of what's traditional programming. You write your rules on any language you want, and then data comes, go through your rules, and then you get the answers. So that's the basic idea of traditional programming. When we start to talk about machine learning, we are changing things around. So how does it work is, instead of writing the rules, they might be too complex for you to write. And we'll get into that in a little bit, but the idea is you got the answers and you got the data, and then you give it to a machine, and the machine will write the rules for you. So that's basically what machine learning does. It figures out all the rules for you. And this looks like kind of magic, and that's a little bit like that, but there is a lot of very interesting developments in terms of computer science that made this possible. Let's go into an example. So if you want to do activity recognition app, you might just use, for example, speed as a variable in your code, and then you can just do, I don't know, if its speed is less than 4, you define that the person's walking. And if you want to also have another state which is running, if it's more than 4, it's running, right? This is easy. If you want to detect if the person is riding a bicycle, maybe we can change a little bit our if and else there and add some more rules, and then we can do walking, running, and biking. And this can go on, but it cannot solve every problem. For example, if the person is doing golf, right? So how can we create a rule that will say, oh, this person is playing golf? How can we do that? And the answer is that that's not easy at all. and that's where we come back to our visualization of programming, and we can see here that the traditional programming is not going to solve that problem easily, right? That's where we are going to come back to machine learning and try to answer that question. But now the question is, how do you get answers and data? So we come back to our activity recognition app, and if we use the information about accelerometer, gyroscope, and everything from your phone, for example, and those are, let's represent that as those numbers, what we know is if we get this information and we label them as, oh, I was walking during this time, and this is the information from my phone sensor, and I was running at this time, and then you give that information. So you label that properly, and then you just go and they say, and give that to the machine. It will train a model that can figure out that there are patterns on your sensor information that can indicate with certain precision that you are walking, that you are running, or biking, or golfing. So this is something that you cannot do by hand. That's really, really too hard. So this is what machine learning is here for. Let's take a better look into that. So how does this work? Okay, I have the data, I have the labels, and now how does the machine understands and give you an answer? How does that work? Let's try to see the process around here. So at first, what the machine does is it will, when you start training a model, that's what training a model is. When you start training a model, the first thing the machine will do is get some data and make a guess. It will guess, receive some sensor information, guess it's walking, it's running, for a lot of data. The next step is you see how close to the proper answer is the machine, right? So the random guess will give you whatever accuracy it is, but you measure that. You have to measure. So is it too far? Is it too close? Am I close to? Is the machine random guesses close or not? After you measure that, you can come back to the machine and say, look, you made some mistakes and you are super far. Can you try again with try different answers here? And you keep repeating this process on and on and on. So this is the process of training. The machine will make a guess, and then you measure its accuracy, right? Measure how close it is to the answer. And then you get these answers from the machine, and you optimize them. And optimize them is saying, hey, you are, let's say you're giving values too high, values too low. Maybe you should, and then the machine will figure out, oh, I'm guessing too high number, let's say. And then you try a lower one. And you keep doing this with your data for some time until it gets to a point that it can, based on your data, and on the labels, it will make absurdly good guesses. And then the accuracy will drop, and you have like the loss of you will drop, and you have a very good accuracy. And that's the process of training a model, right? So you come back in here, and just to have another view on what's going on there, you give data. This is the first drawing there is the training process. You give answers, data, the machine process, and give you rules. The other part of that is using those rules, right? And we call that inference. So after you train a model, you have a good model that you train for a long time, and then you can use that for inference. Using for inference is giving data to a model. The model will run on this data and give you an answer. So for our activity recognition, you will start walking with your phone. The phone will detect, oh, you're walking. That's one inference, right? And doing training is much slower than doing inference, of course. So we need to understand these two steps, because it helps you understand where you can deploy your model and what's happening on your deployment environment. So you have training where you create a model, and you have inference where you use your model. Those are the basic concepts about machine learning. I'm not going to go into details on the math behind it, how it works. It takes a while, and I guess we don't have that much time. And let's try to understand how TensorFlow can help you with that, and why that would be a good thing to learn. First of all, what is TensorFlow, right? So TensorFlow is a framework that helps you build machine learning models. It's open source, free, and end-to-end. In this end-to-end is very important. I'll come back to that in a little bit. And it's start developing here at Google, of course, and then we open sourced that in 2015, and it's been under heavy development since then. Last year, Jeff Dean is the VP for TensorFlow. Last year, he published this one. If you can see there, it's on 12th of May, and we had passed 100 million downloads, right? And this is cool and all, lots of downloads since 2015. But as of this year, we are already on 200 million downloads, and we have more than 52 million views on our tutorials and guides on tf.org, almost 10 million views on our blog articles, almost 10 million views on our YouTube channel, and we have more than 800,000 learners on Coursera and Udacity courses around. So this is a good thing that there's a lot of people using TensorFlow as of today. What are the goals of TensorFlow? Make machine learning easy, simplify as much as possible, and still give you a super powerful tool to be available even for the top researchers or for developers or for anyone that's trying to use that. And of course, be as scalable as possible to be able to train your models on multiple machines, as training some models might take days, right? It can go from, 5 minutes here in your machine to days on data centers. So this is not something that you can do in any way you want. You have to think about that so you can even finish training. And who are the people we pay a lot of attention to? So first of all, researchers. And here I mean researchers in terms of those people that are pushing the boundaries on machine learning itself, right? So computer science and people that are studying machine learning, trying to create new models, new architectures, solving new kinds of problems. These people, we of course aim to have an amazing tool for them. We of course pay attention to enterprise, which are the big companies that want to use machine learning to, for example, detect outliers, detect fraud, to do sentiment analysis on their with their clients, with the users of their apps, and there are others. And of course, we pay a lot of attention to developers, because these are the main people that will use TensorFlow, right? And if we think like researchers, there's a bunch of people. Developers are way more people, and we want them to be able to also use this powerful tool, right? So we pay a lot of attention to these three groups of people, and to give them the tools they need. And when I say tools, there's a lot of them. So as I mentioned, TensorFlow is not just a library for machine learning. It's a complete framework that goes from creating your model that we can see on the left side there, I guess it's left, where we have TF datasets, we have Keras API, we have distribution strategies, and we have a lot of toolings to deal with performance, to having a model repository. For example, we have TensorFlow Hub, where with 2 lines of code, you can already use a model, right? Download a state-of-the-art model and use that on your pipeline, on your app, wherever you want. And we have also the deployment side, where you can deploy your model on a server to create an API, or you can deploy that on a mobile device, on your phone, Raspberry Pi, on an iPhone, or you can deploy on a browser, or on a Node.js server, or on an Electron app, or you can even use the model with a bunch of languages, of course, C, Java, and multiple others. So we have the tools to get you all the way from all these boxes. And let me go a little bit in explain some more of the tools. Aside from those, we also have a lot of extensions that are created by researchers, created by community. So here we have a lot of those, and they help you build models, help deploy models, help tune models, to help you get proper solution for your problem. So we have, for example, one example here is TF agents. That's one extension to help you create reinforcement learn agents. So reinforcement learning is the part of machine learning that you, if you see those cool news about, machine learning won the Go match, won the chess match, won the StarCraft match. So those are reinforcement learning agents, and that does that. So it's a little bit different from what I explained to you, but it's the same idea. And TF agents can help with that. And there's a bunch of others. We have TF Quantum, so you can try to deploy your model using quantum machines, and so on and so forth. Multiple tools. So it's not only those I mentioned, there's a lot of those. Aside from that, we based our API on a Keras API. Keras is a API by itself, but we use that as our main API on TensorFlow, right? So you can see Keras over other frameworks, and it's the same API that we use on TensorFlow to make things easier. It's if we have enough time, I can show you a little bit of that, but the idea is to make understanding a neural network easier, right? Because it's it can get really complex really fast, so we try to make this as easy as possible. This is our main API. Let's take a look on some real-world applications and where people are using machine learning these days. Of course, Google used that on a lot of places. The maybe most common use of machine learning is maybe Gmail with a spam filter. We have, of course, recommendations. We have battery analysis on Android to help you get more from your battery. We have a lot of things. I'm not going to go into details on those. Of course, Google search has a lot of machine learning behind that. Assistant, of course, but all of them, there's a lot of apps using. Let's take a look on 3 of them. The one in the left is called Hold For Me. It's a feature from Pixel devices that, I don't know, when you call somewhere and then there's the music that you have to keep listening while nobody gets the phone on the other side, because the queue, there's a lot of people in the queue, you are number 10, you have to wait, and then there's a music. So what it does is you use this feature and it will listen the music for you, and then you can do something else. When someone picks up the phone on the other side, the phone will ring you and say, hey, someone is here, and then you can come back to the phone. So it allows you to do other stuff that's not listening to that music. Aside from that, of course, we have Google Translate that you can point the camera to a text. It will run some OCR, which is getting text from image. It will figure out which language it is, and after that, you'll translate to the language you want. So that helps you with a lot of things, like, for example, reading a menu in another country. Or seeing signs on the street, lots of things. So Google Translate does that. Of course, machine learning. And we have also the HDR Plus camera from Pixel devices also that does HDR Plus uses machine learning just as the night vision, where you take pictures on a very dark environment and it will make it better for you. All of this is machine learning, and this specifically runs completely on your device. They work completely offline. If you put airplane mode, all of them will keep working, right? So you don't need any connectivity to make them work, which is also another advantage here. Aside from that, we have another example that was published last year where the ZSL, which is the zoo here in London, they have, of course, a research center, and they use audio detection to detect when there are shots in the forest, in specific, I don't remember the country, sorry, but they detect shots so they can, when someone's shooting, because those might be poachers hunting for animals, so they can send the rangers there to look into what's going on. So this is something that helps, because it's very hard to monitor a forest, as you can imagine, right? It's too huge. So if you have these devices, if you have these sounds which they track, and then they can figure out where poachers attack most, and then they can put their rangers around there. So they used TensorFlow, and to be more precise, they use a model called YAMNet to detect this and help them fight poachers, right? So this is a cool example. There's one example that was posted today, by the way. So there is on Pixel phones, you have a car crash detection, which what this does is whenever you are in a car, and I hope nobody ever needs this, but if you're in a car and there's an accident, and the phone will detect, and if you don't press something to stop it, it will call emergency and bring help for you. And this is something what was posted today is that there was a driver that got into a trouble, and the phone called the emergency and got to him, and he was super happy with that. And here we have an example of how we train those models. As you can see, multiple phones in the car and with a dummy, and it crashes, and they get the sensor data so they can create a model. So this model is super interesting, and it can really help, right? So because it has to figure out that if you are in a car crash instead of dropping your phone, right? It has to figure that out, and that's what they did. So this is a very good use case. And last one, just to be more uplifting instead of car crashing, we have this bunch of experiments and demos from the Magenta team. Magenta is a library in TensorFlow that helps you deal with art, right? So music, images, and sound that helps you be creative. Here, the specific example I'm pointing out is the Sketch RNN, where this demo specifically, you can go there and you can get the computer to help you draw anything. So here, you can start drawing, for example, a fire truck, and the machine will complete for you, right? Which is really cool. This is a very, very nice example of using machine learning just to play around with that. Of course, maybe you can argue that's not the most useful, but it's fun to learn and it's fun to play with it. My daughter loves playing with that. There's another link that I shared. That's the experiments.withgoogle.com/collection/AI, which have a lot of very good demos of using machine learning to do cool stuff if you want some ideas. So this is that. And then we got to the point where, okay, this looks interesting. How can I contribute or be part of the community? So in terms of contribution, as you can see the graph there, even in 2020 where things were crazy, there is a lot of contribution from third party. People are always helping improve the framework, and that's amazing. And how can you contribute to TensorFlow? There's multiple ways. Of course, the main one that people think is code. You can write your code. And this, of course, it's challenging in terms of the framework is really big. And contributing, you have to understand a lot of code. So there, if you follow that URL there, there's some tips on how to get started, because you can find some easy problems and start from there and build up. But not only code, you don't need to do only code, right? You can, for example, improve some tests, create some more tests for some functionalities you're using. You can help with documentation. You can help translating documentation, which is absurdly important. That makes the framework better for a lot of people. You can add example notebooks, for example. If you did a cool example and you want to share, you can submit a pull request to the repository. You can help review and comment, pull other pull requests, report issues whenever you find something. Please report them, star them whenever you think they're important. This really, really helps improve the ecosystem, improve TensorFlow as a whole. Also, a cool thing that helps and contributes to TensorFlow is whenever you, do a blog post, paper, article, or social media, you talk about machine learning and you use TensorFlow, just mention that so people see and can come with questions. That really helps. If you want to contribute even more, of course, transparency is very, very important. We do everything in the open for TensorFlow. And one thing that if you want to do a bigger project that's not only fix a bug or improving some logs, you can create a new feature, and we have a process for that, which is we have RFCs, requests for commenters, where you can create one and discuss with the community your idea and go from there before any coding. Of course, there's this. We have a lot of those. We have, I guess, 80 going on right now, or so for multiple projects, improving multiple parts of TensorFlow. So just go create. If you have a big project, for example, that's hard. Creating a new component for TFX. That you can bring a RFC that is very specific for you, and then people help you write that better to have a more broad version. And then after it's accepted, you can just code that and help improve. This is one thing. Of course, I mentioned about translating, creating more resources in other languages also helps a lot. And we have translations from the community for 13 languages, I guess. So there's a lot of people contributing to the documentation. This is hard. It's not for anyone to just go there and translate or use an automatic tool. There's a lot of nuance there. I guess machine learning is not there yet to translate all the docs, so this really helps. Aside from that, we have specific interest groups, SIGs, right? That does with specific parts of TensorFlow. And what does it do is like a community that talks about a specific part of TensorFlow. So here, for example, we have all of these already going on. They have monthly meetings. So we have a SIG for TFJS. TFJS is the library to run TensorFlow models on the browser, right? So they have a interest group that people come, discuss new features, discuss what's going on, share. So they do that every month. You have one for TensorBoard, which is the debugging tool, let's say. It's how you can understand how your model is behaving. So this is important too. We have multiple, and you can join one of those groups, or you can create one of those if there's a specific need. And then from there, you can create RFCs or even map the community around them, around those specific areas, and you can contribute there. So in summary, TensorFlow as a framework for machine learning to solve real problems. Use it in a lot of places. I give just some small examples, some cool ones, and would love to have more people be part of the community and help play with that. And that's it. And I have a question for the organizers. How long do I have? Hello? 15 minutes. Okay. Okay. Let's do something. Let's do something really fast. I have one example here. Oops. If you want to go to this URL here. Yeah, sorry, I didn't copy that. Let's see. Nice. So let me give you one example of how to run, just to train a model, right? So this environment that I'm here is called Colab. Colab is a IDE, let's say like that runs completely on that runs on the web. And what it does here, it gives me a IDE, and all the code is run on VMs on Google Cloud, right? And this is free. You can just access and play. This is completely free. You can just go and play with that. Just follow the URL that was posted. How can that be free? This, of course, has some limitations. You don't have the super amazing, most advanced hardware, but you have GPU access, you have TPU access, which are very specialized chips to train machine learning. Let's go into some here. What I'm going to do is I'm going to create a model that does solve this equation here, right? Of course, you can say, oh, but this is very easy. I can do a code for that. Yeah, that's completely true. But let's start with somewhere first, right? We cannot fly before we crawl. First thing we're going to do here, we're going to execute this. So what's this doing? Okay, yes, I agree. Run anyway. It's from Google. I guess I trust them. So here, what I'm doing is I'm running this. So since it's the first cell, it's first connecting to a VM somewhere. And I can see some more details here, but I'm not. So, and then I'm, of course, this is all in Python. So if you don't know Python too much, you can read and understand. Just bear with me. So here we are going to just do the regular imports, putting the dependencies we need. And the main one, of course, here is TensorFlow. And from there, we are going to use something called Keras, which is the API. And here we are going to create a model. Model is basically, this is a neural network. And my neural network will be just one neuron. So what I'm trying to do here is, remember the machine will make a guess. We measure accuracy, optimize. Guess, accuracy, optimize. The machine will make a guess of one number. It will try to find one number that given one input, and that number you can get an output. That's all the machine is going to try to do here. So it's absurdly simple. So let me do this again. I don't know if I did, but it doesn't matter. And then we need to compile our model. When we compile our model, we are telling TensorFlow, look, to do the accuracy, we need a loss function. We need to know how far we are from the correct answer. To do that, we're going to use a loss function called mean squared error, which is a very basic one. If you did any kind of math in your in college, I guess you've seen this. Again, not going into details into the math, but this is a simple one, and it will tell you how far you are from an answer, from the correct answer. And SCG is a stochastic gradient descent, which is how you tell the model, hey, you are your values are too high, your values are too low. This is how you tell the model how to optimize, how to fix their answer. Let's do this. I don't know if I did. And now we need some data. I only use this six points as data. So this is our data. Remember, I give data and I give labels. The labels are these ones, right? So the equation I'm trying to do is y is 3 times x minus 1, right? Is it? Plus 1, right? This is what I did. Let's see the data here. You can see here those dots. Those are the data. So this, we have the x, which is the data, and we have the y, which is the label, right? Now we just train a model. Poof, let's do here. We are train this for 500 epochs. What does it mean? Remember when I mentioned in the past, make a guess, how far you are, optimize, try again. So every time you do this once, this is 1 epoch, right? So we are trying that for 500 times. It's since this model is absurdly simple, it's very fast to finish. And here we have it. It's ready. Our loss is super low. So if we try this, let's think which should be the answer here. Let's pretend nobody saw that. If we try to use the model, this is when we call model.predict. This is the part, the inference part I mentioned. Remember, I give now new data, and the model will use what it learned to give me an answer, right? So this is the predict for 10. We should expect, let's go back to our equation. PPP, 3 times 10, 30 plus what? 31. So let's suppose it will give me 31, right? Let's execute here. And it gives me almost 31. And this is something you have to learn about machine learning. This problem specifically is a regression problem, right? I'm trying to find a number. I'm not trying to classify in which if it's a dog or a cat, which is very basic. I'm trying to find a number. It didn't give me exact number. And machine learning is not about exact numbers anymore. It's about a number that's very close to the main answer. If we keep training for more epochs and with more data, we might get closer and closer to 31, but that's not something we are aiming for. We don't aim to super precision. We aim to a number, and we give you like accuracy. You can say, oh, this is 98% accuracy. And then you have to learn how to deal with that. This is another part of machine learning, how to deal with the answers you get, right? It's not like it's not as precise as regular programming. Let's take a look on our equation here. If we plot, the green here is our equation. And this is the simplest code you can do with TensorFlow, right? We just trained a model to solve this equation here. If you can play with that, change whatever you want. This Colab by itself is a great place for you to play with stuff and learn, because you can just keep changing. When you don't want to use this anymore, just close the tab and go. That's it. And of course, this machine will be claimed back after a couple of hours. And if it detects that you're not using it, will just tell you, look, you're not using, I'm going to close, blah, 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 close, and give the machine to someone else. So this is, don't worry, play, change whatever you want, copy, make a copy to your drive, put on your GitHub, doesn't matter. Play around with that, and this is an amazing tool. This is simplest code TensorFlow you can write, and that's it. I'll go back to the presentation. Colab, I mentioned. I could go over the explanation, but I prefer to use the code to do that. And thank you very much.
Thanks a lot. I think I really like that you started with the machine learning paradigm. You talked a little bit about the batch and real-time inferencing, but I was really surprised to see the nice examples and the demo in Colab. Indeed, the OCR, I see myself a lot in real life with clients all over the world. But the car crash versus the dropping phone example for me was really interesting because I think often people don't really realize how often we already use these types of technology to with such cases. There are plenty more of examples like real-time license plate recognition and so on, in which TensorFlow and/or other frameworks can be used. So we do have some questions already.
Oh, nice. Of course.
I think the first question was, what is JavaScript TensorFlow.js?
So TensorFlow as the framework for you to build your models, first of all, it can be used for a lot of languages. For example, you can use from C++. You can load a model in C++ and use that. The difference for TensorFlow JS, for TensorFlow for JavaScript, is there's two things. You can create a model exactly like I did in Python. You can do that in JavaScript. Same thing. Very similar API. Or you can get a model from TensorFlow, regular model, convert TensorFlow JS. And why would you convert? Because the model you use in your browser, remember, it's running on your browser. It's not running on a server that's connected to your browser. It's on your browser. So the model has to be downloaded to your browser. Given that, this model cannot be like a 1 gigabyte model for language understanding, right? It has to be way smaller. So when you convert this model, the same thing is for phones. When you convert this model to run on TensorFlow JS, the TensorFlow JS library will be able to load this into memory, and then you can do inference. So there are a bunch of examples where you can do face tracking with a lot of dots, and then you can move your face and it will move Barack Obama's face. I don't know, mirroring your face. Or there is one cool model called Iris. I forgot the complete name. Which it does is it knows how far I am from the camera, given the size of my eye. So that's the kind of thing that would never be able to do with proper classic programming, let's say, right? Because it can measure, and it does for all different people. We are all different. It measure, it can do that. And there's a lot of other, they can do hand tracking and all those kind of things. Everything you can do in TensorFlow can do also on TensorFlow JS. And since we have an amazing JavaScript community, right? I guess they would like to play with TensorFlow too.
Okay, thanks a lot for your answer. A second question is around the SIGs. So Kubernetes has SIGs for topics like mental well-being as well. The question is, are there also TensorFlow SIGs for not really directly technical topics?
That's a good question. I don't know if there is, but if you think that's a good idea, I would definitely suggest you submit to us hey, I want to create this SIG for mental well-being and or other related stuff. That's definitely something we want more people to do. And yes, if you think if you want that, please send an email. We can work on that.
Okay. I myself really was very happy that you very briefly touched upon the subject of reinforcement learning, because reinforcement learning is a technology that's starting to be used more and more often, but it's really only good in very specific environments. And I was wondering, in what type of environments do you see use cases in which reinforcement learning is used? And do you have anything to say in that space?
Well, there's for reinforcement learning, the main use case that people think about is playing video games, right? So you think, I'm going to create a bot to play video games. But then stay with me. So you can play a video game, right? And then what's the value for a company to have a bot playing their video game super well? And then I'll tell you one value. First of all, testing your game. If you have a bot that can play your game super well, you can leave it testing your game nonstop, like stress testing and finding stuff. So if it plays like a proper human being, if you can make it play closer to, instead of being super good, being just human, you're going to find multiple patterns and say, oh, maybe you should improve here. It's slow. There's a bug. Also, maybe something you could do is there's a bunch of things you can do on that, on quality for games. That's one, right? Another thing is recommendation system. A recommendation system can be built around reinforcement learning because it's a system that's hard. All recommenders are hard, right? We can do one with that will learn your behavior or the behavior people like you, and then can tune the kind of notifications we receive, the kind of products we receive. So reinforcement learning can also help on that. And the other thing is reinforcement learning can help you on other parts of machine learning. So for example, when I talked about StarCraft, right, they build a bot. It's not all reinforcement learning. It's impossible. There's a lot of other models working together to have one agent that can win. So that's also cool. It's not like reinforcement learning will solve by itself, but it can work with other supervised learning models to help you solve problems. So this is this. Oh, one other example for games. As you can see, I play some games. There's one specific use case that I don't know if you've been playing against someone, and they drop. They drop. All of a sudden, they drop for whatever reason. Connectivity. Their mom's calling them for dinner. I don't know. Whatever. So that's annoying, right? Because now you might win, whatever, but it's... So what if there was a bot that can continue their play style?
Okay.
And just continue. There doesn't need to be... I don't want to beat the hardest AI. I want to compete with the person I was competing already. It's the same level. So it's not being superhuman. It's being human. And this is something that I imagine people might be doing that already. But that would make online gaming better, right? For example, if you're in a team and then someone drops, you are automatically in disadvantage, right? Unless you're a Daigo. But if you're not Daigo, you're going to lose. The thing is, if there is a bot that can come and just replace that person and not be a dead body there, just help you, you get a better experience. You don't even need to know that's happening, right? You might know later if the person tells you that they drop, but then keeps your experience better. So this is the kind of thing that reinforcement learning can help.
Thank you for the examples. I have one example myself that I'd like to give because it's totally different. It's actually a drone that's in the water and it scans boats. And so it takes pictures of boats, and when it detects a crack, but the probability is not high enough that it's really a crack in the boat. So let's say it's 0.75 accuracy, then it will automatically take new pictures until the accuracy is either high enough or low enough for the other algorithm to be sure whether it's a crack or not. And I'm really very impressed by how reinforcement learning these days is popping up more and more. Yeah. I think another hot topic nowadays is model transparency. Is there anything specific that you need to do or that you already have that can help with that transparency, especially especially for public sector and so on? This is also a question that comes back often.
So there's when you talk, this is more in the field of responsible AI and how you can have a model that's fair, that has it's fair to everyone, that takes privacy into account, that's not biased into some people, for example. So we have a complete responsible AI toolkit on tensorflow.org website where we can help you create model cards. Model cards are like explaining what our model does and tell you, look, this model does A, B, and C. It's good for this situation. It's not good for that situation. It has these bias maybe from the data set. It has, and it give you all the information whenever you use a model. It's like medicine, right? You read the medicine, you say, oh, this is not good if I am, I don't know, if I just swam, if I'm, I don't know, anything like that. So the model will give you this kind of information. Look, this model is good for A, B, and C. So the model card is a good thing. We have a TF privacy that helps you understand how to train your model in a private way with taking privacy into account. And this is a hard problem because not every model can be trained with privacy in mind. But it can tell you, look, without retraining your model, it can tell you how good it is dealing with privacy. So you can imagine, I don't know how much that affects EMEA or Europe in general, but for example, in some countries, you can calculate credit, how much you can lend to someone, right? Imagine that database has address. Address is absurdly biased, right? Because if you live in a poor neighborhood, you're automatically tagged as, I'm not going to lend money to this person. So how can you take that from your data, from the analysis? Because people think that's, no, you have to have that, that's important. That's not important. That's a bias that we have with us, right? Having that's very easy to exclude a complete neighborhood, right? But it's not how machine learning should be used. So we have tools to that for that.
Okay.
Can I add something into the
Of course.
ethical side of this? I think when you said that last thing you said about it's not how machine learning should be used, I think there's a lot of things where not only checking that the model is fair, but also asking your question, is it ethical to even use machine learning in this situation? Like I've had people ask questions about using it for hiring algorithms or different things like that. And I'm just like, I don't think it should ever be used in hiring. And that's my opinion, but it's just, there's too many possibilities for discrimination when there's already so much unconscious bias within hiring already. And so I think when you're starting to do machine learning and you're starting to think about problems, it's not only making sure you're excluding those features that could attribute to issues, but also asking yourself first, should I even use machine learning for this?
I guess the machine learning is I was discussing with someone that's way smarter than me that machine learning is like a magical hammer, right? That you can nail everything. The problem is some things are not proper nails, and so what happened there's for the hiring specifically, there is an algorithm for that. There was a blog about how amazing it is, and then someone got okay. That's first of all, when you see that the model can detect a good hire, can detect your gender, can detect if your age, there's a bunch of those that are absurdly biased, but people think that they really work. So there was for hiring. Someone did that, and then someone, oh, let me test that. And then you're on a Zoom call, right? Or Meet or whatever, VC. And then the scores, when they put books in the background, are way higher with the same person, same position, they just change the background with books. That's a clear bias there, right? It's that your algorithm is not telling you anything about the person aside from, oh, there's a book in the background. That's not a hiring criteria, at least not that I know, right? Unless, I don't know, you're trying to hire someone that has books in the background, then might be a good thing.
I think, yeah, I mean, these algorithms that help with hiring or not hiring people are used a lot, I know. But I think in the end, it's all about balance, because sometimes we as people might even be more biased or biased in a different way than algorithms. So the fact that we can combine both our human perspective and something that's supposed to be objective, but might not always be, it's really nice evolution.
It is, but it's tough, as Cassie mentioned. And the one thing is that sometimes when people say, "Oh, there's a bias here," and sometimes I read about this every day, right? Even sometimes people say, and is there something here? And then you think a little bit and say, "Oh, got it." And then so it's not always obvious what's the problem, but as soon as you figure that out, you should at least, oh, look, there's a problem here, and then you tell other people. So that's how you learn, right? Sometimes it's not obvious, you just tell and help fix.
Well, thanks a lot for the talk and a nice conversation. I will give the word to Cassie.
Thank you. Yes, that was a wonderful introduction to machine learning. You covered so much topics, even from the art side, like talking about the Google Magenta, which I've played with before and I love. And there's just so many things you can do with it, with machine learning and with TensorFlow. And so our next guest, we're going to look at another open source library that you can